We're going to start our unit on motion, and that means we have to be able to be familiar with some terms and just some things that we're going to use throughout the rest of the year. And one of those things that we're going to use is the idea of a vector. Okay? And so let's start with position. If I want to know where something's at, describe where I'm at.
You are about a meter in front of me.
About a meter in front of you. Okay? There's three pieces of information in that position. Okay? And position is something that is a vector. There's lots of different kinds of vectors. Okay? So let's see if we can figure out what makes position a vector. You said a meter, 1 meter, in front of you. Okay? That. What is that?
Okay, that's just a distance.
It's a distance. It's a measurement. It tells me how far, how much, how many. Okay? That is part of a measurement.
Okay.
In front. What's that?
That was a direction.
Okay, that was a direction. These two things together make up a vector. So we have the magnitude, which is a number.
Okay, so magnitude is the 1 meter part.
Right. We have a direction, which is self-explanatory, right?
Direction.
There's lots of different ways we're going to end up using direction. It can be negative, it can be positive, it can be left, it can be right, whatever. In front works. Of you, this is not part of the vector. This is part of the position.
Okay.
That thing right there. Okay, so magnitude and direction, these make up a vector.
So vectors have magnitude.
This is what we call a reference point.
That makes sense. That's what I had to give in order to give your position. I couldn't just say you are at this place. I had to say what I was measuring from.
Right. If I wanted to say you get to my house, I can't say just drive 14.
Right.
You need to know 14 miles, and you need to know what direction, and you need to know from where. Okay, so all of those things are helping. So position is an example of a vector. There's going to be lots of examples of vectors. Okay, and magnitude and direction, and reference point is also necessary for position. Now, usually we're not interested just in where something's at, but also in how far it's changed, how far it's gone, how far it's moved. Okay, so let's say a person starts right here, okay, and we'll call this the reference point. So we're going to measure everything from right here, and they go this way, 5 meters, before they turn around and come back this way, 7 meters. I want to know how far they've gone.
Well, I'm not sure what you're asking, Mr. Auwerda, because I could say, well, they walked 12 meters. Or I could say they are 2 meters to the left of where they started.
12 meters or 2 meters left.
So are you trying to trick me?
No, but you are getting at something. I should ask a more precise question. When I say how far have they gone, you should say, well, exactly what you said. What do you mean? Do you want to know how far they are from where they started or how far do they actually walk? And since those are two different things, they get two different names. This 12 meters, where did you get that?
I just added 7 and 5.
5 plus 7 equals 12 meters. Okay, this is the distance they walked.
Okay, so the distance that person walked is 12 meters.
Vector or scalar?
Scalar, because I didn't give a direction with that.
Okay.
So scalars do not have direction.
It's a scalar. It does not have a direction. Okay. 2 meters left. Okay. Where did that come from?
I took 7 minus 5.
And 7 minus 5.
5 minus 7, I guess it doesn't matter.
Equals 2. Well, now that's interesting. You say it doesn't matter, but 5 minus 7 is not 2.
Well, negative 2.
It's negative 2.
But it doesn't make sense to say I would negative 2 meters, does it?
Well, you didn't just say 2 meters, though, did you?
I said 2 meters left.
2 meters left. Now, what we've inadvertently done is we've assigned directions with signs. Okay. If we say negative 2 meters and we know negative is to the left, this way is negative, which makes that way positive.
Oh, so the negative isn't saying, like, how big it is. It's implying the direction you went.
Right. So we can use negative signs to indicate a direction. Okay? And so this negative indicates left. So 2 meters left, is this a vector or scalar?
It would be a vector for sure, because I see magnitude of 2 meters and I see left for direction.
Okay.
But what if I had said negative 2 meters? I walk negative 2 meters. Is that still a vector?
That's still a vector. That negative is, instead of saying left, you're saying negative. It's indicating a direction. Okay. So negative 2 meters, this whole thing, that's a vector. If I just want the scalar part of it, or the magnitude part of it, I guess, we would just say 2 meters. We would leave off the negative.
Okay.
Okay. So magnitude tells me how far, how many. That sign gives me the direction.
Okay, so the magnitude isn't negative 2 meters, you're
No,
saying?
the magnitude is not negative 2 meters. It's just
Magnitude is just 2 meters.
2 meters. And since this does not include the entire path that they traveled, it just says starting to ending. Okay, we can't call it distance. We got to call it something else. We call this one displacement.
Displacement.
Okay? And displacement is a vector.
Okay, so distance and displacement are pretty much the same, except displacement I need to have a direction on.
No,
No?
no. Okay, and here's what I mean when I say no. Let me start a new picture. Okay, you start here. You walk here. Let's say this distance is 3 meters. You walk here, another 4 meters, and then you walk all the way back 7 meters. What's your distance?
Well, the distance I walked would be 14 meters, right?
3 plus 4 plus 7 is 14 meters. What's your
but
displacement?
Displacement, I'm just looking at where I am compared to where my reference point is, right?
Right.
So my displacement then, I guess, would only be 0 meters.
Are they the same?
No.
No.
But sometimes they could be the same, right?
They could be the same, right? If I had stopped, if I said, well, let's ignore that. If I had stopped right here, then your distance, 3 meters
Okay.
plus 4 meters, would be 7 meters. Now, that's still just a distance. If I want to make it a displacement,
I could say 7 meters to the right.
7
or
meters
something,
to the
or
right.
Positive 7
positive
meters.
7 meters. Okay, you'd have to make it a vector. Okay, so they can be the same as long as there's not a direction change. When there's a direction change, then things tend to get a little bit weird.
Okay.